All right, next we have the coefficient of determination, which is given by r squared. So the coefficient of determination is actually the square of the correlation coefficient. So if you take the correlation coefficient and you square it, meaning you multiply it by itself, to itself, then you'll get the coefficient of determination. Now, the coefficient of determination will always be a positive value between 0 and 1. The coefficient of determination can be converted into a percentage. So if the coefficient of determination was equal to 0.44, then that would convert to 44%. Now the coefficient of determination is the percent variation. Let me bring this down. It's the percent variation in y that can be explained by the variation in x. So what that means is it's the amount that the x variable increases. It's the percent by which the amount of the x variable increases is the cause for the amount that the y variable increases. So for example, if we had a line of regression for this, this was a previous example. This is the correlation coefficient. To get the coefficient of determination, we would just take this and square it. And that would come out to 0.4397 or 43.97%. What that means is 44% of the variation in the final score is explained by the third exam score. So here we're looking for correlations, and we want to know, does the score on a student's third exam, have much of an influence or a bearing on the student's final score? And what the coefficient of determination says, that only 44% of the increase in the third exam score is responsible for increasing the resulting final score. So this would probably indicate that it's not a very strong effect that the third exam score is having on the final exam score. Even though they're correlated, even though you can draw a line of regression, through the data points of third exam score versus final score, the coefficient of determination is low. And so we can kind of look at, the flip side of that. So we can do 1 minus r squared. And this is the percent of the variation in y that cannot be explained by the variation in x. So for example, with our example of 44% there, let's see here, let's click that. Then 1 minus, sorry about that. Let me clear some of this away. Okay, then 1 minus 0.44 gives us 0.66 or 66%. So what that means is something else other than third exam score is responsible for the increase in the final score. I put 66. That should have been 56. All right. And that's just what I calculated there. So this is all we're going to say right now for the coefficient of determination. All right. Let me know if you have any questions.